G'day there guys, Elfie here. This video is some of the in-class footage from my first lesson in the animals cell I created. The reason it's sort of edited and cut down quite a bit is quite a bit of the lesson was spent with my camera in-game standing still and me wandering around the classroom, talking to kids and having discussions with them. So what I've decided is to sort of compress it down into just what I think are the good discussions and explain to you before each with a bit of a video clip of me just walking around the cell and talking to you as I am right now about what's coming up and what it means and how it affected the lesson. So this first clip is the introduction of the cell to the kids and sort of explaining to them how to move around and what's the expectation and things like that. You'll have to excuse the audio quality. I'll try and tweak it as much as I can when I'm editing, but it was recorded on the inbuilt mic on my laptop, which isn't the best, but it took me about 5 to 10 minutes to work out what the issue with my mic was and get it fixed. So after this first section, it does get better. Enjoy.
What does it look like? Guys, for the description, I obviously didn't read this out. What I want you to do is describe what it looks like. I say it in there somewhere, I thought. For all organelles, you should be describing their basic shape and structure. You should also think of some strategies you could use to remember what they look like, their role, and also how you're going to be able to recognise these basic structures in diagrams or photomicrographs. Alright, because what I've got in there for you, alright, is literally just my idea of what a cell looks like. If you have a look at the front cover of that booklet I gave you, okay, there's two others that I got off the web. Alright, if you have a look at the exam questions, they have other ones. Alright, so when you're describing them, when you're writing a description, what do they look like? Generally, the information block is kind of in front of the organelle you're supposed to be looking at.
Alright, and as you're going around, guys, you'll see the organelles. Once you work out which organelle is which, you'll see them from different angles. Alright, so you might want to go back and make some more notes about what they look like once you get there, because the Golgi is the perfect example of this. The viewing platform for the Golgi is not necessarily going to give you a good idea about what the Golgi looks like.
Okay, this next clip here is a discussion I was having with a student that wasn't engaged in the task and didn't seem to want to be engaged. So it's just me, and I've gone away and come back a couple of times, which is why it's a bit cut in and cut out, but it's basically me trying to get her on board and just getting her to have a crack at this as an activity rather than sitting there in the classroom doing. The other thing I will do with these discussions I have with students is I will narrate them. You'll see the narration going across the bottom of the screen, sort of with what the students said to get to this point in the discussion and so on.
What you up to, Sam? Apart from making yourself dizzy.
It's stupid.
Why?
I hate
Why? What's stupid about it?
games.
No, this isn't a game. This is learning. This is just a different way of learning.
Don't like it. I prefer to do this stuff.
But did you do that stuff?
Yeah.
So answer it then. Forget about that. Go through and write the description of all the organelles and what their roles are. No, without the book. No, you said you'd done it.
No.
Sam, this is what I'm trying to explain. Hang on, just stop and listen for a second. Sam, stop and listen for a second. This is providing you with a different way of learning than just using the book. That's the whole idea. All right? You haven't even tried it. What I'm asking you to do is try it. Okay? If as a class we decide this isn't the way forward, or you as an individual decide that this isn't the way you want to learn after today, that's fine. I will come up with another strategy for you. But I would like you to actually have a go today, please. You understand? Can you have a go today for me? Thanks, Sam. I'm asking you to try it. Okay, Sam, if you're going to be stupid, okay, all I'm asking you to do is try it today. Okay, what I've done here is something that I've never done before and you've never done before either. Alright, all I'm asking you to do is have a go, do your best.
Why is that colour?
Well, that's fine. That's fine. You don't need to have. You don't have to answer every question. All right.
I don't know what photo is either.
Have you read the block?
Yeah.
Well, what did it say about that? About? No, I don't want you to copy that down for the description. The description is what it looks like.
Yeah.
All right. What's the role of the vacuole? That was in that information. Okay, it's in there. You can use your book alongside if you would like, but I would like you to have a go at this. All right.
Okay, this next clip is a discussion with a student about how my interpretation of the cell and his interpretation of the cell and the Golgi apparatus and how that would look was different, and trying to get him to connect with what I had to what he had, and it came through because I had examples of other pictures or diagrams of cells. He was able to connect his understanding of the flattened pancakes to the pictures and then therefore link that to my creation in the cell.
Oh, I get it.
What's really small for a cell? No, I'm talking to Chris. Yeah, I'm asking Chris. What's really small for a cell?
I think I had a Golgi pattern, a series of flattened pancakes.
Yeah.
I imagine that they have like a string of little flattened pancakes. Is that wrong?
Okay. You can imagine any way you want. As I said originally, this is just my interpretation of what a cell looks like. Here's another couple example. There's your Golgi there, or there.
Oh.
All right.
Okay,
So
that makes
it's just an example.
But then how
So-
can you say what's inside it?
From
Is
the-
it inside the flattened pancake?
From the angle you've got here is not the best angle to view. I realised last night, the Golgi. So as you go further around and have a look at some others, have a quick look back at the Golgi and see what you can see.
Yeah.
All right.
This next clip shows possibly my favourite conversation of the lesson. I had a student say that the block I used for creating the cell membrane was not what she would have used, and then she went on to explain what she would have used and why she would have used it and what she thinks of when she thinks of the cell membrane. So it was this discussion that for me really brought home the fact that having an environment to learn in like this is completely different to anything I've done before. Because I've taught cells several times over the last few years, because I've been teaching for about 8 years now, this is the first time anyone said, I think it should look like this. And that was a really powerful moment for me as a teacher, to sit there and go, well, these kids have opinions, these kids come with ideas prior to what I've given them or trying to give them, and that is something that I don't normally bring out of the kids, which is a big failing of mine, I think, and this is helping me, I think, to address that and value the kids' opinions and be able to talk to the kids about what it is they think and what they would do different if they had that opportunity.
What did you write?
For what?
You just said something, some fancy word I wanted to hear again.
Translucent?
Yeah. Why do you think I made the cell membrane translucent?
I don't know. What if there these actual, like walls outside it?
Okay.
And that, like, maybe the cell membrane would have been made out of something different, like some sort of, not water, lava or something.
Okay. Okay.
Because
Okay.
when I think membrane, I think stretchy, kind of
Yeah. So okay. All right.
yucky.
Yeah. No, that's cool. That's cool. I was just you said that word, and I just wanted to find out what you were talking about.
There are a couple of discussions throughout the lesson about the difference between the rough endoplasmic reticulum and the smooth endoplasmic reticulum. The one I've chosen to show you is probably the clearest audio, and it's trying to get across to the kids that learning isn't necessarily a linear thing, and particularly with the way I created this map, you need to go left and right and all over the shop to get the full picture. So this is sort of an aha moment for this student later on as well, where he connected why I was trying to get across to him what the ribosomes do, what the difference between the rough and smooth ER are, and how that impacts on the functioning of the cell.
Rough and smooth, they have different block.
So what's the block that's there, the extra block? There's another organelle, I think I say that in, if you read it. There's another organelle in there, in the cell that has that same block.
Seriously, this texture pack is awesome.
Wait, there's also a cell membrane?
Right, so have a look around and see if you can find the organelle that's made out of the same block.
I get it. The rough one has the same block as the ribosome.
Okay.
Is it because the rough ER also reads RNA and stuff and does protein?
No, read about the ER as well, because that'll help tie the knowledge together.
I've already done the smooth and the rough one.
Oh, you've already done them both. So what's their role in the cell?
They can modify amino acids and move stuff around.
Right. So they're modifying that amino acid chain which the ribosome makes. So why would there be ribosomes associated with it, do you think? It's that association that makes it rough. So you've got ribosomes stuck to the ER as such, and that's what makes it the rough ER. Why do you think that might be?
I don't know.
Well, the standalone ribosomes don't finish off the protein. The ER does.
So they're there to finish it off?
Yeah, so they actually do the modifications to the protein to make it a fully functional protein instead of just a chain of molecules joined together. So the ER is what does that. There are some proteins that just form up properly when they're being made, but a lot of them need modifications done to them to make them.
That's what the rough ER does.
And that's what the rough ER is, one of the roles of the rough endoplasmic reticulum, yeah. Yep.
Is that the extra block?
Yeah, that purpley coloured one. So what other organelle has that purpley coloured block? If you turn
We were
around,
just talking about this, me and I were just talking about it.
all
One,
right,
isn't it?
that one, yeah.
Okay, this is the last clip coming up, and this was a discussion with a student based around his prior knowledge about the cell membrane, cell wall, and he was getting confused between what was what between the cytoplasm and the cell membrane, and he thought animal cells had a cell wall. So this was a discussion trying to explain that to him, and you'll hear other students interject. So it's a really powerful learning space where students are happy to help each other out, as well as listen to me as a teacher trying to guide in the right direction.
Because that's what it's... No, cell membrane is everything, all right? The animal cells don't have a cell wall, remember? Only plant cells have a cell wall. So there is no cell wall in this cell. There's only the cell membrane.
So it's clear, we can't see it, really. Is that what we're trying to say?
No, that's the cell membrane.
No.
All right? What keeps the stuff outside the cell outside and the stuff inside the cell inside.
I just suppose like kind of the goo that floats around within the walls.
Ah, that's something different that I haven't put down in your book. All right, that's the cytoplasm.
Yeah, I was going to say, I read that.
All right, or cytosol is another word you might be able to use for it. Okay?
Okay, that's it for this video, guys. Thanks for taking the time to watch. This first lesson is over, but the students will be going back in probably next week to finish off their learning in the cell, and then we'll be revisiting this map further into the future when we want to learn about energy transfer or protein synthesis or something like that. So I'll continue updating you guys and uploading videos similar to this one. So thanks again for taking the time to watch, and I hope you enjoyed it.